So yes, I'm going to give you basically an introduction to data ethics. Now, the way that I prefer to do introductions to ethics, keeping in mind that there'll be people in this room with sort of a range of disciplinary backgrounds, plenty of data scientists, computer scientists, people from the humanities, social sciences, philosophy, industry, sort of all over the place, is not to go sort of too deep into theory, which I think is what a lot of introductory ethics courses end up doing. You end up just talking about the difference between deontology and consequentialism and don't really get anywhere. What we're going to do is basically look at the scope of issues that are covered within data ethics and some of the more recent problems or recent challenges that we're looking at in relation to data science. So there's a number of cases that we'll look at. So this will be hopefully slightly more hands-on than other introductory courses you may have been to. And I encourage you to ask questions while I'm talking and as well as at the end. So if something doesn't make sense, if you need clarification or just something pops into your mind, please just raise your hand and I'm happy to take questions while I'm talking. I prefer this to be sort of an interactive approach rather than just me lecturing for an hour or 2 hours. So with that out of the way, just an outline of what we'll talk about. First, we'll talk about what data ethics is and why we need it. We'll talk about different ways of approaching data ethics, and that's the only bit of theory within the talk. It's very short. Then we'll look in a bit more detail at the ethics of algorithms, which is one of the branches of data ethics. I think a particularly relevant one in the past year or two. And then finally, towards the end, we'll look at two cases in a bit more detail. One being the issue of opacity, how to overcome opacity in algorithmic systems, and how to explain them if it's possible. And second, at fairness, or measuring fairness in algorithmic decision-making. So there'll be a very interactive component of those two cases. So to start off, what exactly is data ethics? Well, it's inspired by the fact that we have more devices now. Those devices are connected, they're collecting data, or they're generating data, they're processing data about us. And the growth in terms of data output and also the capacity to analyze data does not look like it's going to stop or abate at any time soon. And so basically in data ethics, we try to make sense of the ethical implications of data generation and data analysis rather than concerning ourselves with specific technologies, which has been the approach in the past in ethics. So we've gone through a phase where we had computer ethics, which started in the 1980s, is still going today, which was looking specifically at the ethical implications of computers, different types of computational devices. But in data ethics, basically we're concerned with data itself. Another thing that motivates us is that we're producing not just large volumes of data, but many different types of data, and data that can reveal unforeseen things about our lives. So this picture that you're seeing here is basically an overview of structured and unstructured data types that are relevant to medical research. And the point here is that whereas traditionally you may have had clinical trial data, public health data, sort of observational data to rely on to do medical research, now you can increasingly repurpose other types of data that themselves seem to have nothing to do with health, but actually when combined with other sources end up being able to reveal something about your health. So the things that we're able to do with data and the potential invasiveness of those new ways of looking at data is sort of one of the central motivating factors. And this causes problems not just in the space of ethics, but also in any approach to regulating data collection, data analysis, so basically in data protection and privacy law. And some of the things that we'll be talking about today will sort of bleed over into the regulatory context a bit because there is this very close coupling now of data ethics and data protection, especially with the new general data protection regulation set to come into force next year. There we go. So just to give you sort of a more formal definition of what data ethics is, it's inspired by three things. Again, the generation and the ability to process greater amounts, greater types of data than has ever been possible before. To do that processing, we need algorithmic systems to make sense of data, which can be automated, which can be human run. But in other words, we need new ways of looking at the data. And finally, once we have the data, once we have a way to actually look at it, there'll be lots of different practices that are now becoming increasingly data-driven. In other words, the traditional sort of practices that we have, things like medicine, are now increasingly being driven by the insights that we can generate from this data that we're producing. And so if you've been to a GP in recent times, I imagine the experience, if it was anything similar to my last experience with the GP, is most of the time was spent looking at a screen rather than actually looking at you as the patient. And basically that's just a sort of very small reflection of medicine, which has traditionally been sort of a doctor-patient practice, is increasingly becoming a doctor-patient data practice. You're able to find out quite a bit about patients from the data that they produce, sort of independent of what they're able to tell you in the actual office or clinical interaction. And so, of course, there's a number of practices that are being impacted, both in the sense of how they're performed, but in also sort of the norms or the norms of good practice. So, for example, what it means to be a good doctor can be changed by the increasing availability of data, even if you're talking about something as simple as sort of liability for looking at all the data that a patient would give you. So these three things together, these three sort of sectors together, or types of concerns together, are what we call data ethics. Now, sort of a formal, more formal, I suppose, approach to that would be this picture on the left, which just gives you some idea of the sorts of issues or the sorts of concerns that we look at within these three different branches of data ethics, or the ethics of data science. So in the ethics of practices, again, we might be looking at how deontological codes of behavior are changing. We might be looking at how consent changes as you're able to repurpose data, potentially without input from the patient. On the data side, we're taking another look at traditional concepts like privacy, how new chances or new potential for re-identification of individuals, and also the privacy of groups. And the ethics of algorithms, which we'll cover in the most detail today, we're particularly interested in how you assign responsibility or accountability for the actions of algorithmic systems. And so just to quickly flag up, so obviously we'll have 2 hours today to sort of do a very quick introduction to what data ethics is, but if you're looking for a bit more detail about any of the topics that I'm covering, there's a number of papers that I can recommend that really cover the same area but give you some further reading to look at, give you a bit more in-depth analysis than we might actually get into today. So the first that sort of defines the field is What is Data Ethics by Luciano Floridi and Rosaria Taddeo, who are also Turing Fellows here. There's also a paper I did a couple years ago called The Ethics of Big Data, essentially a review of ethical issues in relation to big data specifically. There's another one came out last year about the ethics of algorithms. And then finally a sort of a survey of computer ethics going back to 2002 that was released a couple years ago as well. So these are good resources if you're looking for a bit more detail about the things that I might skim over today. And so finally, before we move on to why we need data ethics, I think one of the things that sort of motivates us to look at ethics from the level of data itself rather than specific systems is that quite often the issues that you're looking at are based more on the function of a system rather than its specific combination of hardware and software. So an example of that would be if you have basically a threat detection system, in this case an airport. Now from this perspective you could imagine this being a system that is based on cameras. So there would be cameras in a system in the background doing some sort of analysis of the passengers within a terminal, trying to predict their age, their gender, their relative threat level, the relative happiness, very simple example here. But you could just as easily have this sort of system embedded in a robot that is patrolling the terminal and flagging up potentially threatening passengers to a security team, for example. And the reason this is relevant is not just because quite often we end up talking past each other in ethics, but also because that sort of tendency, I suppose, to talk past each other, at least to look at systems as having unique issues rather than sharing the same sort of problems, ends up being translated into regulation. So we're seeing this, for example, right now in Europe, where there's separate law being proposed in relation to smart robotics versus AI versus just data protection in general. We're talking about systems that are all processing data. They're all going to share some core issues because you have that sort of common functionality, but the approach that we take in ethics and in regulation doesn't always reflect that. So why exactly do we need data ethics? This is where we start to get into what will motivate us in terms of the problems that we're facing. So obviously data science provides huge opportunities to improve private and public life, but you have a number of ethical challenges that are coupled to it, related to fairness, responsibility, respecting the various human rights, and a number of other issues that we'll go into. And the problem is, if you don't sufficiently look at these issues in the design phase and the deployment phase, if you don't take them seriously early enough on, then you risk basically hindering innovation or hindering the sort of benefit that data science can bring. So we're very much advocating a foresight approach to ethics rather than a reactive approach, which is quite often what you get in ethics. And so a good example of this sort of double bottleneck that can happen is the Caredot data program, which I'm sure everybody in here is familiar with. But basically that program to essentially spread or make access to patient records in the UK, or certain types of patient information in the UK, more easily accessible to researchers, both within the private sector and the public sector, was hindered not necessarily because of inherent problems with the approach or with the idea of data sharing itself, but rather because the issue of consent was not taken sufficiently seriously and thought about hard enough in the phase where they were actually notifying patients that this program would be rolled out. The primary way that they were notifying patients was through basically a leaflet that was passed through your post box, which was taken to not be sufficient. So to give you a number of cases here to start to understand what some of the problems we can get from these systems are. So the first would be that the types of systems we're looking at, algorithmic systems that are processing greater amounts of data and changing practices, is that they have increasing levels of autonomy, or at least increasing levels of complexity that can lead to unintended behaviors. So a good example of this would be, and it's a relatively benign example to be fair, but a good example of this would be, there was a study done on Wikipedia bots that basically spent years fighting each other in these silent, tiny battles over basically, it can be something as small as changing punctuation or changing a word in a Wikipedia article. And they get stuck in these sort of endless feedback loops where one makes a change and then the other reverts the change. And of course, this is not an intended behavior of the bot at the point it is designed. It is an expected behavior when they come into interaction with each other, but at the time the bot is being designed, the designer may have no knowledge that the other bot exists. In other words, they may not know that it's going to get stuck in this sort of feedback loop. They're not going to know who they're doing battle with, so to speak. And when you have systems, even if they're not autonomous in the sense of making decisions themselves, or they're not learning systems, even if they're just sort of simple, very simple pieces of software that are following well-defined procedures, you can still have these unexpected interactions between them. Another example of this would be the various flash crashes we've seen over the year owing to high-frequency trading. Another perhaps more, newsworthy or at least attention-grabbing example of these unintentional behaviors was when Microsoft released their Tay chatbot. I think that was last year already, or maybe earlier this year. But basically, it was a chatbot if you're not familiar with it, it was a chatbot on Twitter that ended up being trained by the internet to essentially be a horribly discriminatory, racist, misogynistic, not person, but bot. So in this case, it was you would assume that was not the intended behavior of the designers at Microsoft, but rather this was an effect of who was training the system. So in this case, it was users of Twitter that were chatting with it to train it to say certain things. Not in a one-to-one sense, of course, but rather there was some sort of concerted effort to break this thing, in other words. A second problem that we face is a lack of foresight. So there's a good example from, I believe it was in Boston, of the Street Bump app. If you're not familiar with this app, it was essentially an app that you would install on your smartphone, and it would use your accelerometer to detect potholes, or at least roads that required repair while you were driving around a city. And of course, that sounds great. It gives data to the city to be able to target the repair efforts, to be able to send crews out to places where they know particularly bad potholes exist, to sort of prioritize these potholes. But the thing that happened that was not expected, I think reflects a lack of foresight on the part of the planners, was that it ended up that potholes are being fixed much quicker in richer parts of town. Now in this case, the reason for that is because the people that could actually afford a smartphone and therefore be able to install the app on their phone had to have basically certain means. So it was directly linked, in this case, the prioritization of fixing the streets was directly linked to the citizens' ability to pay, not in the sense of ability to pay the city to fix them, but rather just to afford the underlying technology. The fact that there might be this disparity in terms of who could actually afford smartphones was not taken into account when they were designing the app, or at least not when they were deploying it. In the sense of they could have used this as just one among a number of other data sources that they recognized as sort of inherently biased and adjusted the prioritization accordingly to that. A third problem we face is that oversight of these systems is incredibly difficult. And this owes both to the many different unpredictable things that you can do with the data that's being produced, but also just the scale of these systems. And so what you're looking at here is a map produced by the Health Map project at Harvard back in 2012 that basically maps all the different places in the US that patient data can go. So what you have is just a map of basically the different types of actors that could receive some information about the patient and then use for whatever purpose is necessary for them. Now, the point of this is mainly to look at where the patient lies in this. So the patient has this huge range of potential recipients of their data that in some cases maybe what they're using the data for will be fairly obvious. So for example, when data goes to their insurer, the insurer is going to be keeping some record of the claims that they're making, maybe adjusting their premium, and you can sort of imagine what they're using it for. But it's not always the case where it's very clear what the data will be used for. So even if the patient is able to keep track of all the different places their data is going, knowing what the data is actually being used for in all those places is a huge challenge. And it's not something that can't be overcome, of course, but it's just to suggest that you have this sort of greater burden placed on the individual by these systems. Oversight of these systems sort of inherently places this greater burden on the individual that we haven't found a great way to deal with yet. We've had calls for sort of regulatory bodies that could act on behalf of individuals, but even that is incredibly difficult just because you're dealing with so many different types of systems and so many different types of sectors. So how to set up oversight is one of the biggest challenges that we end up looking at in the field. A fourth challenge would have to be the distributed responsibility of these systems. You'll quite often have algorithmic and human actors or algorithmic and organizational actors working together. How you then assign blame for the actions of the algorithmic system is an open problem. There are approaches in law to deal with it. So for example, there's discussion about how you translate liability law or how you apply liability law to software. But basically, you have to find some way to actually fairly distribute the responsibility for an action across this network of mixed actors or this network of different actor types. And so this is just an example of a Tesla that, while it was in autopilot mode, ended up crashing into the back of a lorry. So is the fault there the human for not stopping in time because they're, in principle at least, supposed to be in control of the car at all times, or at least have their hands on the wheel at all times? Is it the responsibility of the car somehow? And if so, what would that actually mean? Or is it just the responsibility of Tesla? Or maybe the truck? Maybe the truck has actually done something wrong in this case. And then finally, the sorts of risks that we're dealing with these systems are not just informational risks. We're not just talking about risks to privacy, but we can actually be talking about financial risks, physical risks. So this would be a case of surgical robots. These are mocked up robots, obviously. We're not quite that advanced yet. But basically, we do have types of surgical robots already. So it's not just we're not just worried about privacy in data ethics. I suppose that's the point. It's that we're worried about sort of all sorts of harms that can befall people as we automate tasks that have been previously just the sole domain of humans. And just another example of that would be, Nightscope, which has been in the news a number of times recently, most recently I think for falling into a pond, which was unfortunate. But in this case, you have basically a robot that is responsible for identifying people as a threat or people as a risk, something that would traditionally be done by security, by police, or perhaps by other people on the street. Now, if a robot is identifying me as a threat, I would certainly like to know why they did that, what it was about my behavior that led to the robot, identifying me as a threat. And so that's one of the things that we're going to talk about in detail today is when you actually sort of suffer a harm from an algorithmic system, so when you're harmed in some way, what sort of recourse do you have? What sort of mechanisms do you have to, say, demand an explanation from either the system itself or from its designer, from the company using it, if it was purchased from somebody else? And are there other ways besides just receiving an explanation of why the system behaved as it did to hold these systems accountable? So before we go into the cases, just going to quickly cover the different sorts of ways that data ethics can be approached. And again, this is the one bit of the talk that has something to do with theory. So again, general approaches, this won't be surprising to anybody that's taken a sort of introductory ethics course in any context. We can't help but keep going back to deontology and consequentialism as these two very sort of intuitive approaches to how you can decide how an action, or whether an action is right, or why an action is right, why it is acceptable. And so in the case of data science, deontology essentially equates to the responsibilities of data scientists, whereas consequentialism would have to do with the rights of data subjects and the effects of actions. So again, anybody that has looked at medical ethics before, these principles will seem familiar. But basically, one deontological approach would be to say that researchers, data scientists, working with human subjects or with the data of human subjects, so data produced by people or the devices that they own, need to respect certain principles when they're handling that data. So we need to respect the individual's autonomy. We need to use it for beneficial purposes. We have the famous do not harm mantra from medicine that could potentially be translated into this context as well. And we want to make sure that our actions are just or fair. So essentially, a deontological approach is all about the motivations and the intentions of researchers or of data scientists. Now, one case we already looked at where that obviously fails is in the case of unintended consequences. Again, the designers of the system more than likely had very good intentions when they were designing it. They wanted to create a useful system. And yet, because of how the system was deployed, because of the conditions in the wild, so to speak, it ended up having very negative or very harmful consequences. So following principles or having good intentions doesn't always get you to sort of an ethically acceptable place. So we need some way to make sense of these cases where we feel like something is wrong even though principles haven't been followed or the intentions of the designers were good. So a deontological approach could be said to overlook the unintended consequences of systems, the rights of the people affected by the systems, moral patients, and just the broader impact of data science that are unrelated to the immediate reasons for an action. Now, consequentialists, again, this has to do with the effects or the outcomes of actions rather than the intention or responsibility of the actors. So the effects, the consequences of an action are the basis for evaluating whether the action is right or acceptable. And consequentialism as you would guess, has similar or sort of mirror shortcomings in the sense that it's limited in scope to moral patients, so to the effects on individuals, the effects the system has on an individual, and it overlooks the responsibilities of agents or of data scientists. So both of these approaches have problems. There's a reason we've been talking about them for so long. There's a reason we haven't sort of arrived at a right ethics or right correct theory in ethics over all these centuries. So one other potential approach in the context of data ethics is to take an environmental approach. And so this, this is focusing on the informational environment as a moral patient. I should say that in the advanced course that we'll be offering, I think in February, we'll be covering basically this approach in a bit more detail and how it interacts with the other two approaches and a number of other theoretical approaches. So the advanced session will be sort of focused in much more detail on the theoretical side and how that actually sort of affects how you, or constrains how you design solutions or at least responses to the types of cases, the types of issues that we're talking about today. But anyway, so another potential approach is this environmental approach. The informational environment is treated as a moral patient. So rather than it being a specific set of entities or a specific set of people, such as data subjects being the focus, it's the environment to which the ultimate respect or care are due. So in other words, it is the thing that you are concerned about. The quality of the informational environment is what you are concerned about rather than individuals within that environment. So as a result, if the environment is being treated as a moral patient, then you end up putting the burden on the shoulders of human agents within that environment to be responsible, to show respect, to show care for it. So in other words, they're responsible inhabitants and designers of an informational environment. They'll have moral duties to protect it and to foster its flourishing. So the idea here is that you can essentially try to compensate for the weaknesses of a deontological and consequentialist approach insofar as you will have principles that guide data scientists and data subjects, but you're still looking at the impact or the consequences of actions as well. You're looking at the impact on the informational environment rather than the impact on individual agents within that environment. So it's a slightly different approach. It's not just simply combining a consequentialist and deontological approach, but rather it's sort of tweaking them to try to make them work. And so the idea here is that if you have this information ethics, this environmental approach to ethics, that you have some sort of macro ethics for data science. So in other words, you have ethics that is able to cover all three branches of data ethics, or a theoretical approach that's able to cover all three branches of data science, whereas the other two have shortcomings. So that's the sort of taster on theory. And again, we'll go into much more detail on the theory side in the advanced class if you're interested in that. But now I want to turn to one specific branch of data ethics. So I want to look at the ethics of algorithms in some detail. And so again, this approach will be based on the paper that I mentioned earlier, if you want a bit more detail about it. But essentially, we conceive of algorithms, within the ethics of algorithms, we conceive of algorithms that have occurring at least three different levels of abstraction. First, they can be a mathematical construct, so literally the formula, the abstract version of the algorithm. We can also talk about algorithms in terms of their implementation in a particular software package. So this is when they start to become a thing, not a tangible thing necessarily, but at the very least they start to get, they're implemented for a purpose. And then finally, we can talk about the configuration of that implementation to answer a particular question or to handle particular data. So it's the configuration stage will be different from the implementation insofar as an algorithm would be configured to answer a particular question to handle a particular type of data. And the types of algorithms we're talking about are decision-making algorithms. They're going to be algorithms that make generally reliable but not necessarily correct decisions. They'll be based on complex, often self-defined rules that in some way challenge or confound human capacities for action and comprehension. So in other words, we're talking about the types of algorithms that are not mundane. We're not talking about an algorithm that would automate a factory line that's going to follow a very simple set of steps that is merely mirroring something that a human used to do, in this case the factory line worker. But rather we're talking about the types of algorithms that are processing so much data or taking so many features into account when making a decision that they challenge our abilities to comprehend how that decision was made. Quite often we refer to these as opaque algorithms. And so with algorithms we can have, or basically what we did in the paper was we defined this framework for the types of concerns that you can have with algorithmic systems. What we're trying to do here is to actually provide some sort of framework for discussion of the ethics of algorithmic systems, which is increasingly discussed sort of in the public sector, at least in media as well. And so we can have three different types of epistemic concerns, or concerns with how these systems produce and act upon knowledge. We can have two types of normative concerns, which are just concerns with the effects of the systems, the outcomes of the systems. And finally, we can have one overarching concern, which would be with the traceability of the systems. So if you have a concern in any one of these categories, so for example, if you're concerned that the evidence that the system has produced is not conclusive, you can have sort of an overarching concern about, okay, well, who's responsible for the system producing this bad or inconclusive evidence? I'm jumping ahead there. So in terms of epistemic concerns, basically there are three, I suppose, characteristics of the evidence produced or taken into account by these systems that you can question. So you can question whether it's conclusive. This is essentially the correlation versus causation problem. Even if you think you have conclusive evidence, so you believe the evidence is sufficiently reliable to be acted upon, you can still be concerned that the way it was produced was inscrutable. So you are not able to examine the process underlying the production of that evidence in a satisfying way. And even if you have scrutable ways of producing the evidence, you can still believe it's misguided or biased in some way. So you can believe the input data you had was biased or incomplete. So for the street bump example, in that case, the data was biased because it was missing a huge chunk of the population of the city, or it wasn't representative of the entire population of the city. Now, even if you have good evidence along all those three accounts, you can still, so you have conclusive evidence, you have scrutable evidence, you have well-guided or complete data to make the decision on, then you can still be concerned with the fairness of the decision, sort of independently of the quality of the evidence that produced it. This is where we sort of come into concerns about data-driven discrimination, that if you can try to justify a discriminatory decision on the basis of data, does that somehow make it okay to do? And you can also be concerned about the transformative effects of the decisions or of the outputs, the outcomes of these systems. So this can be something as simple as how we perceive of privacy, sort of the lessening value that some people say, at least, that we attach to privacy because it feels as if the data will fall into the wrong hands no matter what we do. It can also be something as simple as how we talk about the systems. So we talk about algorithmic systems as intelligent. We see them as in some way similar to us, having similar capacities. And in all these cases, again, we can be concerned about the traceability. So is sufficient evidence, is an audit trail being produced by these systems that allows you to assign responsibility for their effects after the fact? Now, as a roughly one-to-one mapping from these concerns, we can identify 7 different types of ethical challenges. And these ethical challenges are basically reflecting what people are discussing in the literature, so what academics are discussing in the literature to describe the ethical concerns with algorithmic systems. And quite often, again, these are one-to-one mappings, but not in all cases. I think that the vocabulary here, the language here might be slightly more familiar in the sense of we're concerned with opacity rather than the scrutability of evidence. Now, besides these challenges, which are sort of widely discussed at the moment, there's also a number of gaps that can be identified that, again, map to one of these types of concerns. So as I suggested earlier, we can be increasingly concerned about the privacy of groups. We'll talk about that in a bit more detail in just a second. We can be concerned about how you distribute responsibility for the actions of the systems. We can be concerned about the phenomenon of de-responsibilization, so basically the idea that if a system is giving a recommendation to an expert, if the expert just blindly follows that recommendation, then they may feel less responsible for the effects of the recommendation. Essentially, the computer told me to do so, so I did it. It's not my fault. And rather than trying to cover all these in any detail, which I think would be both sort of infeasible and testing of everybody's patience, we're going to look at a couple of these both within the cases that we'll be looking at in just a few minutes, and then also just quickly look at a couple of these in a bit more detail. So the first one, unjustified actions. This is not just a question of correlation versus causation, but it's rather a question of when are you actually justified in acting upon the knowledge that these systems produce. So when analytics produces a correlation, when are, besides having a p-value that is sufficient for publication, when are you actually ethically justified in acting upon that correlation? So it's the basic idea of truth versus actionable insights. The types of systems we're talking about will generally not be producing any sort of causal knowledge or anything we would consider truth, but rather they'll be producing some sort of actionable insight. So an insight that somebody takes to be sufficiently reliable to act upon it. And of course, there are risks of being wrong. There's risks of thinking that an insight is sufficiently reliable when it turns out it was wrong, or it was just misguided, or it was, again, based on poor evidence. And so what we need is some sort of standards for acting upon correlations. Again, these are ethical standards rather than sort of scientific standards about what we consider to be sufficient for publication. And also appropriate standards for releasing the tools or the results that we produce with algorithmic systems. So there was a recent case, the Stanford facial recognition case. Happened, I suppose it's over a month ago now, where basically a researcher at Stanford and a colleague from somewhere else produced and released a software package where they said they could predict somebody's sexual orientation based on their face. Now, they claim that they had sort of scientifically valid results here, that the system could do what it could do. But of course, there were horrible or potentially horrible consequences, horrible potential consequences of releasing that in the sense of if it's picked up within a country where there are laws around sexual orientation, then it can lead to the persecution of people in that country, which you would imagine is not the intention of the researcher there. So I think we need some sort of, these are not necessarily standards in the sense of regulation, but rather just professional standards, professional ideals of when we have these sorts of correlations that we think are actually insightful, while we may be tempted to just release them for the sake of getting a publication, we do actually need to have some foresight about what the broader societal effects can be of the systems. And a related question is that when you have an opaque automated decision, so when you have a decision where humans essentially can't follow the logic of the decision making. So in the case of if a neural net is producing a recommendation or a classification, when you're working with that type of system, basically in what context is it actually okay to use those systems? So for example, should there be consideration given to limiting the usage of highly opaque methods in high-risk contexts? Going back quite some time, actually, I think back to at least the 1990s, possibly the 1980s, people were already considering these questions. I mean, a lot of the methods that we're using in machine learning now are essentially old methods. And so when they were being developed, people were also asking these related questions about, well, when is it actually okay to use these systems? There was quite a bit of attention being paid to it, specifically in relation to medical systems, medical expert systems. Basically, that while systems could be developed that were highly accurate, it could be statistically verified, if they weren't actually able to explain their reasoning in human interpretable terms, then perhaps they shouldn't be used because doctors had this independent responsibility to their patients to explain why they're making the recommendation they're making. More recently, there's been there's been discussion in relation to the calculation of credit ratings and health insurance that actually you need to use human interpretable methods in these cases because you have a similar responsibility to the people being affected, to the consumer in this case. And so in the US, for example, in relation to credit ratings, you actually have a law where you have to provide, if there's an adverse decision, you are required to provide basically an explanation in the sense of some reasons for why that decision was made. It doesn't have to be a full explanation of how the decision was made, but rather they actually have sort of an industry standard checklist where it's, I think, like maybe 40 different potential reasons for why you were declined a loan, for example. And basically, you're required as a company to give that sort of explanation to a consumer who was turned down for credit. So that's a case where you actually have a legal responsibility for the company to give some sort of explanation which limits their usage by default of highly opaque methods.
One question.
Yes?
So for example, if the same use case where you have basically insurance option, so does the software provider, or the provider, whoever wrote that algorithm, has to prove it that if that feature was changed, the outcome will be more favorable?
In terms of how they explain things to the affected consumer, no, they don't have to do that. Whether that would be part of any sort of independent auditing or regulatory auditing, I'm not sure about that. I mean, I know there is some sort of auditing that happens, but I don't know in that detail whether they're required to show that. Right, so moving on to another one of the issues that was raised. This has to do with basically how informational privacy is changing in response to algorithmic systems, and essentially how there's a need to start to look at the privacy of groups. So in Europe, the data protection law that we have, both in terms of the member state law that we currently have and also the forthcoming General Data Protection Regulation, which will seek to harmonize standards across Europe, there's this focus on identifiable individuals. So in other words, the entity of concern in the eyes of the law is the identifiable individual. You protect the data of identifiable individuals in order to protect the privacy or the other interests of individuals. Groups are not paid attention to in any respect. And so the current ways that we have, or at least are recommended for protecting individuals, is to remove or hide identity in data sets, to de-identify data sets, to seek consent or some sort of agreement with users, and also to offer some sort of individual control or oversight over data. But the problem is that individuals aren't people in the eyes of the law in the absence of identifiability. So if I de-identify your data, if I can show that it's sufficiently anonymized, essentially you lose your interests in that data, or you lose your rights over that data within the eyes of the law as it stands. Now the problem that we have is that the sort of systems we're working with now, the analytic systems, they treat people as types, or at least they're trying to find small patterns or similarities between people. So it's not really the unique identifiable individual as such that the system is interested in, but rather the way that it can link individual cases to other cases or individual records to other records. And so in a way, a person's identity, at least within these systems, is being shared with other people. Other people that are similar to you, if they behave in a certain way, can then affect you. So for example, if I put you in a group of people and then everybody else in that group defaults on a loan, that's probably going to affect the rate at which you would get a future loan if you're a part of that group. So essentially what we have are these ad hoc groups where it's a group that doesn't actually exist in the sense of, it doesn't exist in the perception of the members. The members aren't necessarily going to know that they're a part of the group, but rather it's something that's being assembled by a third party for a particular purpose, for making a decision, and it's going to be based on these perceived very small links between people. So market segmentation would be sort of a very high-level example of this. I'm talking, though, about groupings that are even more specific than that, more specific than, say, men between the age of 35 and 40 living in London. So these aren't the types of groups that basically aren't paid attention to in data protection law in any sense yet are not collectives, so they're not groups you intentionally join like a labor union, which do have some protections, and they're not ascriptive or inherited groups in the sense of you can be part of a genetic group just based on your genetic makeup. You have absolutely no control over that. But rather, there's something where it's assembled. It's assembled because you're perceived to be similar to somebody else, even if you don't perceive that similarity yourself. And so one of the things we need to look at would actually be how you end up protecting the privacy of those types of groups. It's a very hard question about how you would actually do that, because you're talking about these groups that, at least as far as we're observing the world, they don't really exist. They just exist within a very particular context or within a particular system that's trying to make sense of data that it has available to it to make some sort of decision. And yet, the recommendations of that system can have significant effects on the members of the group. So some further consideration is needed for that sort of privacy. Another common problem would be discrimination. We'll actually talk about this in a bit more detail in relation to fairness in the second half of the session today. But basically the idea here is that even if you have very good, conclusive, scrutable, well-founded evidence, you can still end up with discriminatory treatment or discrimination. And quite often that discrimination will be based on proxy attributes rather than explicitly legally protected attributes like ethnicity or religion or gender. And it's very difficult to actually predict and clean or appropriately distort these proxy attributes before a decision is made. In other words, quite often you only know that something correlates, a feature correlates with race after the fact. Once you see, oh, well, actually, we have, we're looking at all the decisions made by the system, and as it turns out, there was disparate impact that resulted. And so an example of this from not too long ago was Facebook selling advertising based not on ethnicity, but ethnic affinity. So basically people that identify with particular ethnic groups rather than actually being a member of that ethnic group. It's just a way to essentially get around these legal protections against discrimination. I think it presents quite a problem because we're trying to prevent discrimination. The fact that you can find a way around it, purposely find a way around it, does not actually make that right. And the final issue we'll look at before we move over to the cases has to do with how you actually assign blame and praise for the effects of algorithmic systems. I think we've covered most of this already, but actually the bit here that we haven't discussed yet is who should actually be deciding the ethical decision-making rules for artificial agents. So when you have artificial agents that may interact with each other, as we saw in the case of Wikipedia bots, or you have the classic example of the autonomous car that has to decide what to hit, who is it that's actually making that choice, deciding what the appropriate rules are in that case? There's been proposals in autonomous cars to actually give the driver control over that. So you have basically a slider where you say, okay, it's fine, kill me if we're about to run into something, or run over the pedestrians if, I prioritize my life at all costs. So that's one potential solution to that. But the other concerning thing there is if you have that decision made and it's not sort of a dynamic decision where it has to be updated over time, you can end up with essentially ethical norms being frozen in place in systems that are designed. If there's not a way to update the rules either for new users or due to changes in basically notions of good, societal notions of good, then you can end up with systems that inherently have one sort of version of good or one notion of what is ethically acceptable embedded in them that you then have very little control over changing. And in the case of a car, it's very easy to understand how that notion of what is good or what is right expresses itself. It's about where the car drives. But in the case of the types of analytic systems that we've been talking about, where the effects are not particularly noticeable, where they're not easily observable to humans, then being able to detect when you have this sort of freezing of norms can be a very, very difficult thing. And actually measuring the effects of that sort of freezing of time can be very difficult. Okay, so we're about to move into the two cases that we're going to talk about in some more detail and basically get some input from everybody and have a discussion. So that was the lecture portion of today's session, but the next 2 bits will be interactive discussion sessions. And so the first one has to do with the problem of opacity and how you actually explain algorithmic decision making, a topic of sort of increasing interest as we're sort of recognizing all the different sectors and contexts where highly complex algorithmic systems are being used. So essentially the opacity problem, there are 3 dimensions to it. One is the interpretability of the decision-making logic. So in other words, is the algorithm both learning and making decisions in a way that is understandable to humans? You have an example here. I believe this is a neural network that's trying to classify images of cats, I want to say. But it's showing sort of some of the process of how it's deciding whether a particular pixel, I think, is part of a cat or not. So makes sense to the system, but saying precisely how looking at that makes sense or provides some sort of explanation to a human is the issue that we're interested in here. But another very relevant dimension of opacity is the accessibility of systems. So are systems intentionally kept secret to protect trade secrets, or just because there's something going on where the provider of the system does not want you to actually look at it? And also, are there simply technical barriers to actually sharing the system? So if somebody gave me the source code to a system and said, well, here you go, here's full disclosure, you can see everything, have fun, I would be able to do little to nothing with it. Not just because I'm not also given the training data, but also because I wouldn't actually be able to make sense of somebody else's source code. And finally, the third dimension of it would be the provenance of the input data, the provenance of the training data, and also any future inputs. So how is it collected? What are its limitations? How is it labeled? By whom? Is the labeling biased? Is the data itself, the collection method, biased? There's a lot more attention being paid to that, actually, sort of bias in labeling. Quite often, the bias that we get in algorithmic systems has absolutely nothing to do with the system itself. It's just the people labeling the data are biased, or there's actual bias in the world that ends up being reflected in the labeling, rather than somebody doing it intentionally. So quite often, it's very simple human bias that we're talking about, and it just is expressed in these very complex systems. So there's two examples where I think this question of, do I get an explanation of a decision that affects me, has really come to public attention. So this was a piece by ProPublica last year. It has to do with the Compass recidivism scoring system that is used in some courts in the US. And basically what their analysis found was that the system was biased in favor of white defendants versus black defendants. There were essentially more false positives in terms of the risk of someone being classified as likely to reoffend in the future. There were more false positives for black defendants than white defendants based on when measured against actual recidivism in the future. So once we actually know who reoffended and who did not reoffend. And additionally, there were more false negatives for white defendants. So in other words, defendants that were predicted to not be a risk of reoffending in the future that then did go on to reoffend. So the system in that case was found to be biased. Now, there was a case, Wisconsin versus Loomis, which basically tested a defendant's ability to get an explanation of this type of score. So if you receive a recidivism score, risk score, do you have a right under your right to due process in the US to get an explanation of it? And in that particular case, the answer was no, you don't have that. The logic used for that was kind of strange. It was, the judge said, well, the system is a trade secret. Even I, as a judge, do not have access to the system. So if I don't have access to it, then you're not being deprived any information that would otherwise conflict with your right to due process. Therefore, you do not actually get access to that system. Now, this is a problem, at least in my eyes, because you're talking about basically the most fundamental right somebody has, their freedom to not be in jail because somebody thinks that they're going to re-offend in the future. So if you can't have a right to explanation in that case, it sort of begs the question, where can you actually have it? Well, interestingly, relatively recently, there was another case which showed where you could actually have some sort of right to explanation. This didn't actually result in the plaintiff getting an explanation. I'll explain why in a second. But basically, this was a case from Houston where they were using an algorithmic system that was using standardized test scores to compute the value that a teacher would add to the life or the education of a student over a year. And so the idea was your performance would be computed with this system. And actually, firing decisions would be based on it. So if you got a score that said you were entirely ineffective at impacting your students based on standardized test scores, then you could get fired. Many teachers in the Houston school districts did get fired as a result of getting a poor score on this. And the problem was that with these scores, a teacher that 1 year got got the highest possible score was said to have huge impact on the lives of their students, who then went on and taught a similar group of students the next year and didn't change their methods at all. The next year could get a score that was, you have no impact on their lives, and they get fired for it. So there were huge problems in terms of the accuracy of the system as perceived by the teachers. Now in this case, the teachers union sued to get access to the system, basically so that they could verify the accuracy of their scores. They had actually an independent expert that got some access to the system, basically got more access than was available to the teachers that actually received the scores. He didn't have full access to the system, but basically what he said is even with that sort of privileged access, he could not find a way to actually verify the scores. He couldn't arrive at the same scores no matter, even if he knew all the inputs that were being used. And so essentially a decision was made, or they won their lawsuit, which was based on the right to due process. So it was said that if they were denied access to the system, they were actually being denied their due process to fight the accuracy of the score. In the end, they didn't get full access to the system because there was a settlement after that lawsuit. So it was still protected in the end. But at the very least, there was this, in the judgment in May of this year, there was this sort of upholding of, well, they have some right in the case of due process to receive an explanation of how an algorithmic decision was made about them. Again, these are both US examples. There hasn't been a great case of this in the EU yet. Now, in the General Data Protection Regulation, there was some discussion over whether a right to explanation is actually granted for algorithmic decision making. As you can tell from basically it was going around for a while that you would get this right, that you would basically have this unlimited right to receive an explanation of an algorithmic decision whenever you requested one. So it didn't matter where the decision was made. It didn't matter what the outcomes of it were. That you would literally have a right to go to the company or whoever is making the decision and say, okay, explain to me how you actually made that decision about me. People thought it would be hugely disruptive, I think quite rightly. They were calling it the death of machine learning in the EU. And as it turns out, and basically the idea was that you had an explanation to receive, a right to receive an explanation of the rationale of any type of algorithmic decision. Now, as it turns out, that right does not actually exist. Basically what you have is a right, I'm not going to go into the legal details in great detail here, but basically you have a right to receive some information about how a system functions. So for example, you have a right to know that a system is using a neural network to make decisions about your creditworthiness. You potentially could know, actually no, you do have a right to know what sort of data is being used to make that decision. You don't have a right to know which data is the most relevant. It's literally just, here are all the types of data we have about you. We're going to use some of them to make this type of decision. But that's about it. You basically get a general, very broad overview of how the system functions, but you have no right to actually know about how a specific decision was made. You have no right to get an explanation of how your specific decision was made. So what was the logic of it? What was the weightings involved? What were the key features? What were the decision-making criteria? You don't have a right to look at the source code, anything like that. Just a sort of very high-level right. So we call this a right to be informed rather than a right to explanation. Not terribly important for this. If you're interested in the legal basis of this, it has to do with Article 22 in the General Data Protection Regulation. But again, I won't go into that in great detail or why we basically had this confusion over whether there was a right to explanation. The only thing I would flag up is that, so the General Data Protection Regulation will supersede the 1995 Data Protection Directive. Now, the directive was a directive, which means it's not directly legally binding, which means all member states in the European Union had to pass their own data protection law, implementing the directive however they saw fit. The regulation is actually going to be legally binding. The idea is that it gives you some, it's supposed to harmonize data protection law across Europe, although it's really not going to do that. But anyway, under the directive, this is the important bit, under the directive we actually had a right that looked kind of similar to a right to explanation. You've always had a right to obtain from a data controller knowledge of the logic involved in any automatic processing. And what's interesting is that this right has been tested, or the scope of this right has been tested over the years since the directive was passed. In a number of member states, there's been sort of sporadic cases raised where somebody was requesting logic, the logic involved in a decision made about them. And basically what the jurisprudence has decided upon is that what this right means, and you have a similar right in the GDPR, is that you get this system functionality overview. You don't get to know about the algorithm or the method used, the code. You don't have access to the software itself. You don't get to know about the weightings or criteria. You don't get any information about reference groups that are used. It's just this very sort of broad overview. You get very little access to anything that could be perceived as a trade secret. And so that's something that we've had for over 20 years now. It hasn't been greatly influential. And to be honest, it's just sort of coming back into the public eye because suddenly we're concerned about algorithmic systems. And what was interesting actually is, so as I said, we don't have a right to explanation in the new law. There was actually an intention to give us a right to explanation, a legally binding right to explanation. It was in an early draft of the law, but it was taken out. Whether that's sort of it wasn't taken out entirely. It was moved to a non-binding section, a non-legally binding section of the regulation. So whether that was a result of just good lobbying or somebody recognized sort of how disruptive the right would actually be is not entirely clear. But the reason I'm mentioning the GDPR is I think that this case actually tells us a bit about the general sort of approach or the general logic that's being applied to how we want to regulate algorithmic systems. So I skipped over this bit, but I'll actually just go back to the law because it's a bit easier to view it this way. So what you're looking at here is Article 22, the text of Article 22 of the General Data Protection Regulation. That article has to do with automated individual decision making. It's essentially about algorithmic decision making. And the way that that term is defined is that you have a right not to be subject to a decision which is based, and these are the key points, solely on automated processing, which produces legal effects or similarly significantly affects the individual. And then if that definition is met, you get a number of rights or safeguards, so right to obtain human intervention, to express your point of view, and to contest the decision. So that all sounds great in the sense of, oh, I'm going to have some real sort of power over these systems if I feel like I've been wronged by them. I'm going to have the ability to get a human to intervene, to tell them what I think about it, to contest the decision. And unfortunately, those things aren't terribly well defined yet, what they actually mean. There's lots of possible ways that could be implemented. You've always had a right to contest under the Data Protection Act of 1998. The way that's been interpreted is you say, I don't like this decision, I'm contesting it. The data controller says, okay, that's great, we'll just rerun it. Okay, here's the same decision again. And so you don't actually have a right to get a different decision. You have a right to contest it, to say you're unhappy with it. So in practice, what the Data Protection Act has given you in the UK is this essentially meaningless right to say, yeah, could you just hit the button again? Could you just rerun that, please? Now, if you combine that with, rights you have to, say, rectify the data that's held about you, you could potentially get a different decision to be made. But it's sort of a lottery almost, whether you're actually correcting the right bit of data or asking them to erase the right bit of data. But anyway, so gone off on a tangent there, which is not good. So back to this. The interesting bit here is that in that definition of automated decision making, it said that it had to be based only on solely automated processing, and it had to have legal or similarly significant effects. Now the problem is in a previous draft, it said solely or predominantly automated. So what solely automated could literally mean is that if you have even nominal human involvement at any point in the decision-making process, you lose access to all the rights that I described. You don't have the right to get human intervention, to express your views, to contest the decision. It's literally if there's a human at any stage, if it's even if it's a recommendation is made by a system, then the ultimate decision to act on that recommendation is made by the human, you lose your rights against, or basically it doesn't qualify as automated individual decision making. And the same goes for legal and significant effects. It's not clear if they're talking about legal effects just within the scope of the GDPR and what would actually count for a significant effect. That's going to be very context dependent. If I get denied a loan, that may actually have very little impact on my financial well-being, whereas if somebody else gets denied a loan, it could have a huge impact on their financial well-being. So is it a significant effect based solely on your personal situation, or is there some other objective measure? And this, unfortunately, these qualifications are sort of being repeated in other European regulation around algorithmic systems. And so I think that's slightly problematic. So there's other potential solutions for how, basically, if we think a rights explanation is actually valuable, how we could actually give it to people. We could look for new member state law. We could have a watchdog, future jurisprudence, and so forth. But what I'm interested in, and what I want to ask you is, well, first off, do you think a rights explanation is something worth having? And if you do, how would you actually provide a meaningful explanation to a person? So let's say that I've used an algorithmic system to decide whether or not you should receive a loan. And unfortunately, you were denied that loan. And you'd like an explanation of it. What information would you actually want? What information would actually be useful to you? So in other words, what would constitute a meaningful explanation? And is that going to actually change depending on who you're talking to? So for example, should you have your own should you be able to tell me specifically what you want from me as the data controller? So you tell me specifically what information you want. If you're a data scientist, maybe I give you much more detailed information than I'd give another person that has no background in data science. So should the requirements for a meaningful explanation actually change? But I'm interested right now in the first question. So what information would you actually want if you were able to request an explanation? And do you think a rights explanation is a good idea, something we need? Does anybody have any thoughts on that? Yeah.
I guess exactly what kind of data on you is being used in the system.
Okay.
And perhaps some kind of weighting on how each piece of this data is being used.
Okay, so you'd want the weightings for your particular decision. Okay. Do you have any idea what format you would want that in? Okay, and that would be informative to you.
Yeah, so for example, if let's say my nationality is 90% of the explanation, then maybe that's something.
Okay. Okay, so we have weightings, we have the input data, and I sort of took that as the input data that was relevant rather than just all the input data.
Yeah, you have to give only the ones that actually being used, because obviously you can create an algorithm that takes in billions of data points, but only uses 2 and to do prediction.
Okay.
So artificially you could just put more data in an algorithm without really affecting the method. So once you know exactly which ones are being used.
Yeah. Saw him there.
I was thinking the person might like to know what's the one thing or 2 things he or she could do differently for a successful application the next time. So an example of the loan, the classic one is to say, well, don't ask for £100,000 for the house. We would willingly give you a mortgage of £70,000 at that level. You know, so something more actionable that relates to the actual request.
Okay.
So maybe if you change X and Y, and hopefully it's not something prescriptive, right? But
Yeah.
if you change X and Y, you would qualify. So a little forward.
Okay. Well, actually, we're about to cover something like that. It's based on counterfactuals, which is kind of, what you could change. Okay, so, counterfactuals that let you do something about it, in other words. Yeah.
So what I'd like to see in that scenario would be, say, a web page with all the data sets listed that are used in the decision, some sort of slider, a big yes or no on the side, so that I could go in and adjust my age, income, race,
Okay.
race, whatever, slide a slider and see what the outcome is. So nothing to do with my particular data, but what the data sets themselves are used to make a decision.
Okay, so you're talking about the data sets that would actually be relevant to that type of decision rather than your specific value in your specific case?
Yeah, and I could manually
Okay.
put in my own data, see the result, slide some sliders, see if the result changes.
Okay, so but you could put in your data then. Okay, so this would it'd be in some way similar to the car insurance comparison sites that we have now, where you get to change your job title or income, or within reasonable limits, of course. But yeah, okay, yeah.
So sort of starting with the point where I could actually assuming I could make sense of this data or had access to the service that could help me make sense of it, I would probably want access to a reasonable amount of training data for that specific process to begin with. I'd also like an explanation for the specific grouping that I've been identified as
Okay.
for a target, and then maybe an explanation as to the correlations that are drawn for that grouping, let's say in the last 100 applications that received an algorithmic outcome for that decision.
Mm-hmm.
Incredibly complex, I know, but either you have the ability to sort of crunch that kind of data, or there's some helpful soul out there who's an organization, could be anyone, who was able to make sense of it for you.
Okay.
To actually provide additional meaningful context.
Okay, so yeah, you had sort of a third party out there that could actually help you make sense of it if you're not able to yourself. Okay, so yeah, that's quite very detailed what you would want there, but it all makes sense because it's, well, how did you actually sort of, it's almost like saying, how did you come to know me the way you think you know me? Or why do you think you know what you think you know about me? Yeah, so that makes sense. Anybody else? Is there anybody that thinks that a right to explanation is a horrible idea? I mean, I'm basically saying I want to give you more information, so it's very easy to say, yes, I would like more information, thank you. But is there anybody that thinks it's a bad idea? I mean, I think it can be a bad idea, depending on how it's used. Are there any sort of qualifications you would put on it to make sure it's striking an appropriate balance between the individual and whoever's providing the explanation? Yeah.
Is there an option whereby one can say, look, the algorithm says this, but go back 10 years because I'm a dinosaur, a human would have made that decision as to whether I can have that loan or not. Based on that assumption and based on the algorithm being used, whether there is any recourse, because, as you say, if it's solely based on the algorithm and the algorithm says I use this, which means nothing to me because I'm not a data scientist like people over there, it serves no purpose. But as that lady said, if they give me some sort of solution whereby I could improve on those things, it's beneficial. So it's very difficult when you're saying what would help me.
Yeah.
Because it all depends on who the person is.
Yeah, I think that is definitely one of the problems that you end up facing. Is actually, so that's something that's been considered by, there was a little bit of consideration given to this question by the drafters of the General Data Protection Regulation. And just to skip forward, so this is essentially the proposal they came up with for, I should say, there are other rights in the law that actually require them to give you some information about the process. So this is more information about the logic involved, like we discussed. But sort of as close as you get to an explanation within the law. And as you can see, what they had in mind was just icons that would go on a web page and tell you certain things about the decision-making process. So no personal data are collected for purposes other than the purposes for which they were collected. Sorry, processed for purposes, not collected. No personal data are disseminated to commercial third parties. It was basically, this was the level of complexity that they were imagining for any sort of disclosures related to algorithmic decision-making. So very basic, very easily interpretable. Sort of the level of complexity actually that they were proposing was, I think it was a non-expert layperson Well, at some points it was non-expert layperson, in other places it was children, because there's sort of separate requirements for children. But it was very, very basic, at least. So the sort of technical information that others might find useful was at least not what was being imagined. But you mentioned something else about being able to go back to before and having a human make the decision. And that's one of the interesting things about that. Well, sorry, what did you want to say?
Because my assumption is the human wasn't saying because you live in Barking and Dagenham, all of you are condemned, whereas because you live in Chelsea, that's fine. You can all have a loan. And sort of that sort of decision making might not be there when humans were making that sort of decision.
So
Or it was worse. Or it was worse, right? Individuals walked into a local branch and they got looked up and down, and who knows what the decision making was.
Oh yes, obviously there's corruption in that I could give you percentage of the loan and you give me loan. So obviously it's much more complicated. Sorry, I'm just being simplistic.
But, well, I mean, this raises a relevant point, because one of the points made is, this relates more to sort of fairness and algorithmic decision-making and bias, but it's that an algorithm can't lie to you. I mean, unless it's programmed to lie to you, like VW did, but in principle, they can't lie to you in the sense of they're not going to have the intentionality required to lie to you. So they can be programmed to give certain people certain information, but they're not lying. They're just following the instructions they've been given. And so it's very different from human decision makers, and in principle, you could have systems that are more transparent and more fair than human decision makers, because you're actually able to examine the whole decision-making process, and these sort of unspoken assumptions or unspoken biases may be present in the training data, but at the very least, they won't be present in the decision-making process itself. I don't know. That's one idea, is that we can use these systems to make better decisions, at least more consistent decisions. So, I mean, to be fair, it may even be an improvement to say, well, so in that case, bias was very subjective. It could be on a case-by-case basis, whether somebody had an initial reaction to, like, yeah, I don't want to give you a loan. I don't know why, but I just don't want to give you one. Whereas in the case of algorithms, even if you do have bias, at the very least, the bias is consistent, and you can pick up on it over the sort of history of the decisions it's making. But anyway, the bit that I wanted to pick up on was the idea that you can go back to have a human. There's actually this question right now about, so you have the right to contest a decision. And there's a question about how that's actually going to be implemented. Sorry, the right to obtain human intervention as well. And so there's different models or different ways that could be implemented. And one would be that you can actually go back and have a human to make the decision instead of the system. And the human either makes the decision based solely on their own judgment, or they take into account whatever analysis or recommendation the algorithmic system has made. That's actually something that's being debated right now, sort of what approach you should have, both at the European level and then in the drafting of the UK data protection bill. And I should say this idea of sort of right to explanation, where you get a right to explanation, what it should contain, that's being debated as well in the House of Lords right now, for potential inclusion in the data protection bill. So the things we're talking about are very much sort of actual policy issues that are being discussed right now that could have a significant impact on people's ability to get an explanation in the future. Before we run out of time, I just want to move on to the final case. But we mentioned so we covered some potential types of data that could be included. I don't know if anybody said the source code, but at the very least, the input data, the most relevant features for a decision, the weighting, potentially just a list of all the features. There are other types of information that could be included in explanation. I didn't put icons there. I probably should have put icons, since that's a proposal from the EU. And there's this question of what level of complexity do you provide an explanation at? But one thing we didn't touch on is whether you get a holistic explanation or a local explanation. So do you get an explanation of how the model works in general, or do you get an explanation of how it made your particular decision? And this is a relevant question here, because there's a problem. So one approach, I should have prefaced this by saying, there are a number of different ways of providing explanations of both simplistic, interpretable algorithmic decision-making systems and more complex ones, neural nets, and that sort of thing. And so one way of doing that would be a case-based explanation, where you actually basically compare, you find a historical case where you understand why a decision was made in that case, and then you find one of those interpretable cases that is most similar to the case you're trying to explain, and you provide the person with the explanation of the other case. So for example, if I know why I made a decision a week ago to give somebody a loan, and you come in and the decision making was very similar, looks very similar on a number of features to that previous decision, but I'm not able to explain why I'm making the decision in your case, I give you an explanation of the week-old case. That's a very old idea, actually, that was discussed quite a bit in relation to medical expert systems. You provide these case-based explanations where it's just an explanation of a similar case, but not your case. Another approach has been to provide local explanations or approximations. And this can literally be that you are training a simpler interpretable model that acts a similar way to the more complex model you're using within a particular boundary. So for example, I train a model that behaves very similarly to the blue line within these two boundaries. So the red line is the new model, the simple interpretable model I create, and the blue line is the very complex one. Just for the sake of an example here, think of this model that we're representing on these graphs as the question. So somebody comes up to you and asks you the question, how do I drive north? Now, answering that question depends on basically how far they want to drive. So if they're just literally trying to go a couple feet north, you say, well, north is that way. I don't know if north is actually that way, but north is that way. Just drive that way, and you're going north. If they want to go to somewhere nearby, but still within your city, then just pointing them north might not be enough, because they may end up going on a road that goes north at first, but then it doubles back, or it ends in a dead end, or they don't actually get to where they're going. So you need to know where they're actually going. And if they're going to a different city, then maybe you tell them, well, actually go back the other way, but then get on an intercity highway that will head north once you get on it. So you need to actually know basically how far they're planning on driving, how large of a domain you're working with, in order to give them a reasonable explanation or a reasonable recommendation. And so that's essentially the problem that we have with training these local approximations of more complex systems, or just trying to provide local explanations around why the model behaved as it did in your particular case. It's entirely dependent on the domain that you're working with. So if I'm literally just trying to provide an explanation of how the model works based solely on the point at which the decision was made, then I end up with a red line that matches up as close as possible with that bit of the model. If I'm trying to provide an explanation of, say, how it works over this domain, then we end up with a flat line, a very different looking sort of model. And again, you expand the domain further, you get a completely different approximation of how the more complex model works. So while I suppose what's questionable here is whether these local approximations are actually providing you any sort of meaningful or actionable information about how the actual decision-making system works. So this is an active area of research about how you can provide these local explanations that will provide you with some sort of useful information about how the model behaves in the particular area that you're concerned with, in the area where your decision was made. Another idea is to provide counterfactual explanations, going back to the comments earlier. The basic idea here is that people could want explanations in order to understand, challenge, or alter future decisions. So give me something I can actually work with. Give me something I can use to get a better decision. The challenges that we see with explanations are that they can infringe trade secrets. They're technically difficult. They might not be meaningful, and they can potentially expose the system to manipulation or gaming. And so the idea with a counterfactual is basically that you're describing a dependency on certain features or external facts that led to a decision. So the basic form of a counterfactual would be, if Q were false, S would not believe P. So in this case, Q serves as an explanation of S's belief in P, in as much as S only holds belief P while Q is true, and that changing Q would also cause S's belief to change. And so there's multiple counterfactual explanations possible because there are multiple variables in combination, features in combination combinations of features that can alter the outcome or alter the recommendation made by a system. And so the form that a counterfactual explanation would take is this one here. So score P, so your credit rating of 900, was returned because variables V had values V1, V2, and so on associated with them. So you had a number of input variables. They had these certain values associated with them. And as a result, you got score P. If those variables instead had different values, these specific different values, then this other score P prime would have been returned. So it's basically saying if we actually change the input variables, then you would have had a different score or a different output. So a practical example of this was, a practical example of a counterfactual statement would be you were denied a loan because your annual income was £30,000. If your income had been £45,000, precisely £45,000, and everything else remained the same, you would have been offered a loan. And so with this type of explanation, you don't actually have to convey the internal state or the logic of an algorithm. You literally are just giving people potential values of relevant variables that would have gotten them to a decision they actually wanted, to an outcome they actually wanted. And there's all sorts of implications about the utility of these, about how useful they are in explaining how the system works and how you can actually change your behavior in the future if the model changes. But at the very least, they are they're a black box approach. They don't actually require understanding the decision-making logic of the system. And so they're based on this idea of a closest possible world, and they can be generated when you're using complex methods. And again, you don't have this issue of choosing an appropriate domain for a local explanation, because essentially if the individual says, I want to know how to get an output of -10, so I want that decision, then you can tell them precisely how they get that based on and this is just a single variable model. Basically, you're able to use their choice of output as a way to calculate what changes to the variables would need to occur in order to arrive at that output.